Okay. Good evening, all of you. In today's class, we are going to start and finish Bohr's atomic model. So, in Bohr's atomic model, there are some important formulas like the radius of the nth orbit, the velocity of the electron in the nth orbit, the energy of the nth orbit. So, there are some important formulas. So, we'll be going through all of it. So, first of all, there is a hydrogen atom. So we'll begin with that. There is a hydrogen atom. So at the nucleus you have a charge of Z into E. Okay. So this whole thing is hydrogen atom, and at the nucleus the charge is Z into E. So Z into E means atomic number into E. Atomic number is number of protons. E is the charge of each electron or each proton. So at the nucleus you have a charge of Z into E, and the revolving electron, the charge is E. Okay. So at the nucleus the charge is Z into E, and the revolving electron, the charge is E. By the way, let me clarify, I said hydrogen, but it could also be a species like hydrogen. For example, it could be any single electron species. Okay. So it could be hydrogen, otherwise it could be any single electron species. So the charge of the electron is E, and the charge of the nucleus is Z into E, and the radius is R, and the velocity of the electron is V. So these are the data. So what will be the force, centripetal force on this electron? So centripetal force will be mv square by r. So if the velocity is v and the radius is r, so the centripetal force on the electron will be mv square by r. And then what will be the electrostatic force between the nucleus and this electron? So the electrostatic force will be 1 by 4 pi epsilon naught into the charge at the nucleus into the charge of the electron by r square. So 1 by 4 pi epsilon naught Z into E by r square. So this is the centripetal force mv square by r, and this is the electrostatic force 1 by 4 pi epsilon naught into Z into E by r square. So if you cancel one r, then mv square is Z square by 4 pi epsilon naught r. Okay. So if you cancel one r on both sides, then mv square is Z square by 4 pi epsilon naught r. Okay, just excuse me for 1 minute, all of you, 1 minute. Okay, sorry for the interruption, all of you. So mv square is ze square by 4 pi epsilon naught r is the formula which relates the velocity and the radius. Now, one thing is that according to Bohr's model, the angular momentum of an electron is quantized. So according to Bohr's model, the angular momentum of an electron is an integral multiple of h by 2 pi. So angular momentum of an electron is mvr, and mvr will be integer into h by 2 pi. So this is the formula for angular momentum of an electron. mvr is n into h by 2 pi. So you call this as 1, you call this as 2, so squaring 2 and divide by 1, so if you square 2, you will get m square v square r square. You divide by 1, so divide by mv square is equal to n square h square by 4 pi square divided by this ze square by 4 pi epsilon naught r. So this will give you r is equal to n square into h square by epsilon naught into pi into m into z into e square. So this this is actually, you can say that this is the first derivation. Like whatever we wrote here, this is to by comparing the centripetal force with the electrostatic force, and this is quantization of angular momentum. Okay, so these two we are getting like that. But when we square number 2 and divide it by number 1, so if you square number 2 and divide it by number 1, then you will get r is n square h square epsilon naught by pi m into z square. So this is the first derivation, and so this is the first derivation, and according to this derivation, r is n square by z and h square epsilon naught by pi into m into z square. H is Planck's constant, epsilon naught is permittivity of vacuum, pi you know mass of electron, charge of electron. So h square epsilon naught by pi into m into e square. This entire thing it calculates to 0.53 angstrom. Angstrom is 10 to the power minus 10 meter. So h square epsilon naught by pi into m into z into e square is equal to 0.53 angstrom. So r will be n square by z into 0.53 angstrom.
पेमेंट क्या कार्ड में मिलेगा ऑनलाइन मिलेगा? हाँ सर, हेल्प करो खबर से पहले आता है। मैं सीखते हैं।
this combination r equal to n square h square epsilon naught by pi m z e square, and r is n square by z 0.53 angstrom. This is called the radius of the hydrogen-like species. So in this formula, this quantity h square epsilon naught by pi m z e square, this quantity is 0.53 angstrom. This quantity is called the Bohr radius. Okay, h square epsilon naught by pi m z e square, this entire thing 0.53 angstrom. This one is called the Bohr radius. So r is n square by z into the Bohr radius. So this I am calling it as number 1. Okay, this I am calling it as number 1, the formula for r, and in terms of Bohr radius, right? So we have developed the first combination of formulas, radius and in terms of Bohr radius. Okay, now we need to do for velocity. So velocity is nh by 2 pi mr. Okay, mvr is nh by 2 pi, so velocity is nh by 2 pi mr. And so over here, velocity is nh by 2 pi mr. If we put this value of r, then the velocity will come z e square by 2h epsilon naught into 1 by n. Okay, so this value of r, if you go and put it here, you will get z e square by 2h epsilon naught into 1 by n. So ultimately it is coming to z by n e square by 2h epsilon naught. So this is the first thing, that the velocity is z by n e square by 2h epsilon naught, and if you calculate this e square by 2h epsilon naught, then its value is coming 2.19 into 10 to the power 6 meters per second. So if you calculate e square by 2h epsilon naught, it is coming 2.19 into 10 to the power 6 meter per second. So this combination we call it number 2, that is velocity, and velocity in terms of the ground state. So we call it number 2. So remember, the ground state velocity is 2.19 into 10 to the power 6 meter per second. Now this 2.19 into 10 to the power 6 meter per second, if you write it as a fraction of speed of light, like 2.19 into 10 to the power 6, if you write it as a fraction of speed of light, 2.19 10 to the power 6 by 3 into 10 to the power 8, so it will come to 1 by 137. Okay, so 2.19 10 to the power 6, if you divide by 3 10 to the power 8, it will come to 1 by 137, and this 1 by 137 is called fine structure constant. Okay, so I am saying again, V is Z by N, 2.19 10 to the power 6 meter per second, and 2.19 10 to the power 6, if you divide it by speed of light, it will come 1 by 137. So 1 by 137 is called fine structure constant. So we have got a pair of formulas for radius, we have got a pair of formulas for velocity. Now let's move to the next topic, that is energy. So kinetic energy is half mv square, so that is Ze square by 8 pi epsilon naught r. This is the kinetic energy. And potential energy, you know that potential energy is the electrostatic potential energy. So 1 by 4 pi epsilon naught Ze into minus E by R. So 1 by 4 pi epsilon naught Ze into minus E by R. So this is coming minus 1 by 4 pi epsilon naught Ze square by R. So potential energy is minus 1 by 4 pi epsilon naught Ze square by R. So this is the potential energy. So the total energy is kinetic plus potential so minus Ze square by 8 pi epsilon naught R. So this is the formula for total energy. Now in this formula for total energy you remove R and put this. Just remove R and put this value. So if you do that, you will get minus mz square e to the power 4 by 8 epsilon naught square h square into 1 by n square. Okay, so minus mz square e to the power 4 by 8 epsilon naught square h square into 1 by n square. Okay, so the total energy is minus Ze square by 8 pi epsilon naught R. So what is happening is that what is happening is that after we put the value of R and we got this, so we can write it as minus Z square by n square m e to the power 4 by 8 epsilon naught square h square. So the total energy is minus z square by n square m e to the power 4 by 8 epsilon naught square h square. So this will be the total energy. Now according to Bohr, this is what he said. He said that this total energy, it will be a constant. The total energy, it will be a constant in a particular stationary state, it will be a constant. But whenever the electron undergoes a transition from one stationary state to another, then the difference of the energies of the two stationary states will be equal to the energy of the radiation which is emitted. So this is the energy of the nth stationary state, and whenever there is a transition, then the difference of energies will be equal to the energy of the radiation which is emitted. So let us now see the calculation for that. So let's have a look at the calculations. E is minus z square by n square m e to the power 4 by 8 epsilon naught square h square. And this entire thing, m e to the power 4 by 8 epsilon naught square h square, is 2.18 into 10 to the power minus 18 joules. And it is also 13.6 electron volt. So these are the bunch of three equations for the energy. Okay. So I'm saying it again. The energy is minus z square n square. This entire thing will calculate to 2.18 into 10 to the power minus 18 joules, which is also 13.6 electron volt. So this whole bunch is the calculation for the energy. So Hc by lambda is z square m e to the power 4 by 8 epsilon naught square h square into 1 by n1 square minus 1 by n2 square. Matlab, the two stationary states are there, n1 and n2, and the electron is transiting between them. And when the electron is transiting, the radiation is emitted whose wavelength is lambda. So we can say 1 by lambda So 1 by lambda is z square m e to the power 4 by 8 epsilon naught square h cube into c into 1 by n1 square minus 1 by n2 square. So 1 by lambda will be z square into, now this entire thing, m e to the power 4 by 8 epsilon naught square h cube into c, this entire thing will come to 1.09 into 10 to the power 7. So 1 by lambda will be z square into 1.09 into 10 to the power 7 into 1 by n1 square minus 1 by n2 square. So this will be this number 1.09 into 10 to the power 7, this number is denoted by capital R and it is called Rydberg's constant. Okay, so 1 by lambda is z square into Rydberg's constant into 1 by n1 square minus 1 by n2 square. Now this is, you can say, number 4. Okay, this is number 4. So broadly speaking, in Bohr's atomic model, broadly speaking, we have the first pair of formulas that is related to radius, then the second pair of formulas that is related to velocity, the third set of formulas related to energy, and this is related to wavelength, like 1 by wavelength, right? So these are the formulas of Bohr's model, the basic formulas. And I think that in this bunch of formulas related to velocity, I'll also add this fine structure constant. So this whole thing is velocity related, this whole thing is radius related, this whole thing is energy related, and this one is wavelength related. So these are the formulas, the basic formulas of Bohr's model. Okay, now in this last formula, 1 by lambda is z square into 1.09 into 10 to the power 7 into 1 by n1 square minus 1 by n2 square. In this formula, suppose if an electron is transiting from a higher stationary state to 1, so from any higher stationary state the electron is transiting to 1, that means n1 is 1, right? So n1 is 1, it is transiting means it is going down to 1, so n1 is 1, so that is called Lyman series. So Lyman series is UV light. Okay, Lyman series is UV light. So if an electron is transiting from any higher state to the state 1, that means n1 is 1, then that series of spectral lines is called Lyman series. So Lyman series consists of UV light. If an electron is transiting from any higher state to n equal to 2, so electron is starting from some higher state and ending at n equal to 2, then it is called Bama series, and this consists of visible light. Okay, so what is Bama series? If the transition ends at n equal to 2, then it is called Bama series and it consists of visible light. Suppose an electron is ending the transition at n equal to 3, like 4 to 3, 5 to 3, then that is called Paschen series. And Paschen series, it consists of infrared. So any transition which ends at n equal to 3, it is called Paschen series, and it is a series of infrared. So any transition which ends at n equal to 4, like 5 to 4, 6 to 4, so it is called bracket series. So BRACKETT. So this is also infrared. So any transition which ends at n equal to 4 is called bracket, and that is also infrared. Then any transition which ends at n equal to 5, like 6 to 5, 7 to 5, is called P fund, and that is also infrared, right? So this Lyman, Bama, Paschen, bracket, P fund, these are the series of spectral lines and denoted by UV visible, infrared, UV visible, infrared, infrared, right? So this is the total details of Bohr's model. So what all did we discuss in this Bohr's model? What all did we discuss? So we have discussed this. What are the details of velocity of any stationary state? That is this. What are the details of the energy of the NS